In this video, I will show you how to solve word problems that either involve similar triangles or quantities that are proportional. So, problem number 1, a man who is 6 feet tall casts a shadow that is 8 feet long. At the same time, a tree's shadow is 22 feet long. How tall is the tree? A lot of that information is shown in the picture, but the man is 6 feet tall. It doesn't show that in the picture, so let's add the 6 feet into the picture. And let's see, the tree's shadow is 22 feet long. That's shown. How tall is the tree? So we are looking for x, which is this height right here. So let's label one of these triangles as new, and we will label the other one as old. It doesn't matter which one is which. If there's an x involved, I usually pick that one to be new. What's important is that you set up the equation in the form new over old is equal to new over old. So looking at the corresponding sides, new over old would be x over 6. And then looking at the bottom here, new over old would be 22 over 8. 22 over 8. Just to keep the numbers small, I really like to reduce this fraction. So 22 over 8, both of these are divisible by 2. So that would be the same thing as x over 6 is equal to 11 over 4. I'm just reducing. So now I'm going to cross multiply. So if you look at this diagonal, that gives you 4x. And then now if you look at the other diagonal, multiply, and that's going to be 66. So 4x is equal to 66. And then finally we have to divide both sides by 4. And that is 16.5. And since this is a word problem, let's go ahead and add the units back in. So the answer is 16.5 feet. That's the height of the tree. Okay, now this one won't involve triangles, but it involves proportional quantities, which will work the same way. During a workout, Dwayne has run 3.2 miles on the treadmill in 25 minutes. Okay, so he went 3.2 miles in 25 minutes. He plans to run 1.8 more miles. All right, I'm going to color that yellow because I'm doing miles in yellow. So that means that these are corresponding quantities. Okay. Well, you know what? He's going to run 1.8 more miles. Okay, how much longer will he need to run if he goes at the same pace? Okay, so we need the time. We need the minutes that goes with this. All right, so we need x minutes. So I'm going to color that in blue. All right, so let's set up our proportion. And let's see. So we have this pair of values, and we have this pair of values. All right, this pair, I'm going to consider this to be the new pair of values, and I'm going to consider this pair of values to be the old pair of values. And just like with the triangles, I'm going to set up my equation in the form new over old is equal to new over old. Okay, so let's look at the miles. New over old miles, that would be 1.8 over 3.2. New miles divided by the old miles. Okay, now let's look at the minutes. New minutes divided by old minutes. Okay, so that would be x, which is what we're looking for, x minutes, divided by 25. And then we just cross multiply. So if you look at this diagonal, you see that we have 3.2x equals. Now if you look at this diagonal and multiply, so that is 45. And finally, to get x by itself, we have to divide both sides by 3.2. Okay, so that's not a nice even number, but hopefully I didn't make a mistake. 14.06. All right, I'm rounding a bit. Okay, how much longer will he need to run? So this is in minutes. All right, so he would need to, so he ran 25 minutes. He ran 3.2 miles in 25 minutes. So in order to run another 1.8 miles, he would have to run an additional 14.06 minutes. Let's practice that again. On an architect's blueprint for a house, 1 inch on the plan represents 4 feet on the house. Okay, the house will be 32 feet wide and 22 feet long. What will be the house's width and length on the blueprint? Okay, I like to color code these things. So, first let's talk about the blueprint again. 1 inch on the plan represents 4 feet on the house. So we're going to use yellow for the plan and blue for the house. I'm laughing because we should have used blue for the blueprint, which is the same as the plan. But anyway, yellow is for the plan and blue is for the actual house. All right, now here comes the next sentence. The house will be 32 feet wide and 22 feet long. Let's just do one at a time. So right now I'm going to ignore, I'll come back and worry about the length. Okay, don't worry about the length right now. We'll worry about the length later. So just look at the width. The house will be 32 feet wide. So 32 feet wide, that is a length on the actual house. So that's why I'm coloring that blue. All right, now, what will be the house's width on the blueprint? Okay, so the width on the blueprint, all right, house's width on the blueprint, that's what we're looking for. So we're just going to call that X. Okay, so let's just do new over old equals new over old. So we will call this pair, all right, the original pair, I'm going to think of that as the old pair. Okay, 1 inch on the plan, 4 feet on the house, that's the old pair. And I'm going to think of this pair as the new pair. Okay, 32 feet wide, all right, that's on the actual house. And then X inches on the plan, all right? This is in inches, don't forget. So I'm going to set up my equation in the form new over old is equal to new over old. Okay, so new over old. Let's do the blue first. So the new blue is 32. All right, so we have 32 over 4, which is the old blue, 32 over 4. Okay, those are lengths on the actual house. All right, now let's do inches on the plan. All right, so that's going to be x inches on the plan over 1 inch on the plan. X over 1. Okay, well, when something is over 1, you really don't even have to put the 1. So really, you can see that all we are really doing is dividing by 4, which you can really just tell by common sense, but I wanted to go through these motions because it won't always be this obvious. Okay, so, but in this case, it is obvious that we're just dividing by 4. So 32 divided by 4, of course, is 8. And don't forget that this is, on the blueprint, we're talking about inches. Okay, so let's write this down. So right now we are talking about the width. So we can go ahead and say the width will be 8 inches, okay, on the plan. Now let's go back for a second. Let's do the other quantity just using common sense. So obviously, if 1 inch on the plan is equal to 4 feet on the house, if I want to know what a length will be on the plan, it's just going to be 1/4 of this. All right, you know, the feet on the house, that's 4 times the number of inches. The number of inches is going to be 1/4 the number of feet on the house. So that's why you can see right here when we set it up, all we really did was we divided by 4. So it'll be the same thing here. The length on the house, all right? So on the house, the length is 22 feet long. So the length on the blueprint is just going to be 22 divided by 4. And that'll give it to us. And that is 5.5. So the length on the blueprint will be 5.5 inches. Okay. 2 ladders are leaning against a wall as shown, making the same angle with the ground, all right, whatever this angle is right there. The longer ladder reaches 40 feet up the wall. Okay, so this vertical height is 40 feet. How far up the wall does the short ladder reach? Okay, so we're looking for this little height right here. Hold on, I'm going to use green this time. All right, we are looking for this little height right here. So I'm going to put an X here. All right, well, we've got these similar triangles. I'm going to think of this triangle as new, and I'm going to think of this triangle as old. So I'm going to set up my equation in the form new over old is equal to new over old. Okay, so if I look at these vertical pieces, new over old would be x over 40. Now, if I look at the ladder, the length of the ladder, new over old would be 20 over 50. All right, and 20 over 50, see the zeros on the end? Those are going to end up canceling out. Technically, I'm dividing both of these by 10. But obviously, 20 over 50 reduces down to 2 over 5. Now I'm going to cross multiply. So if I do this diagonal, I'm going to get 5x. And then if I do the other diagonal, that's 2 times 40. So that's going to be 80. And then I'm going to divide both sides by 5. Which I think will be 16. Okay, and since this is a word problem, let's use the units. We're talking about feet. All right, 16 feet. Okay, let's do that again. Gabrielle wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the flagpole. So I guess this is a mirror right here. Okay, 48 feet from the flagpole. Then she walked backwards until she was able to see the top of the pole in the mirror. Very clever, okay? In that way, she guaranteed that this angle and this angle would be the same. That makes these similar triangles. Very interesting. Okay, so now that we got these similar triangles, we know that her eyes are 5 feet above the ground, so we know that this height is 5. And she was 12 feet from the mirror, something you could easily measure because it's right on the ground. And we should be able to use this information to find the height of the flagpole. Let's call this triangle new, and we'll call this smaller triangle old. It doesn't really matter which triangle you call new and which one you call old, as long as you write your equation in the form new over old is equal to new over old. So, looking at the vertical lengths, new over old will be x over 5. Looking at the horizontal lengths, new over old would be 48 over 12. That goes in evenly, doesn't it? Right? Because 48 divided by 12 is simply 4. We're just going to multiply both sides by 5. I mean, you could put a 1 down here and think of it as cross multiplying if you wanted to, but it's simpler just to think, let's multiply both sides by 5. These cancel out, and x is equal to 20. This is a word problem, so we should use units. The flagpole is 20 feet tall. Okay, last one. Campsites F and G are on opposite sides of a lake. Okay, here's campsite F, here's campsite G. Fine. In order to measure the distance across the lake, a survey crew made the measurements shown in the diagram. All right. Find the distance across the lake, which is the length of segment FG. All right, that is fine and dandy. We've got similar triangles here. Okay, let's use the fact that we are given right here, triangle CDE is similar to triangle FGE. So let's use that information to sort of match up our corresponding sides. For example, CD is right here, and that's going to correspond to FG, which is right here. Okay, so that's good to know. Let's keep that in mind. All right, that's especially good to know since FG is what we are looking for. So the 47 and the X are corresponding. But what else? What else is corresponding? Okay, look at DE. DE is right here, and that's going to correspond with GE, which is right here. So those are corresponding. And really, this is all the information I need to solve the problem. Obviously, I could go on and match up the 92 and the 82.8, but we only need these four quantities to solve the problem. So let's label one triangle as new and one triangle as old. It doesn't matter which is which, as long as you write the equation in the form new over old is equal to new over old. Okay, for these yellow sides, new over old would be x over 47. Now for the blue sides, new over old would be 73.8 over 82. Time to cross multiply. All right, if we look at this diagonal, we have 82x equals. Now, if we look at this diagonal, 47 times 73.8. $3,468.6. Okay, and of course, the last step is to divide both sides by 82. $42.3. Since this is a word problem, let's get the units in there. This is all in meters. All right, so the campsites are 42.3 meters apart, or the length of the lake is 42.3 meters.